Some scientists believe that an alien meteor that crashed on Earth could hold the key to understanding the nature of interstellar objects. Recently, observations have confirmed that the solar system has seen an increase in visits from interstellar objects, some of which have even crashed on our planet. Let's take a closer look. Interstellar objects have been passing through our solar system since the dawn of time. But it hasn't been until recently that we have had the ability to study these visitors closely. One such object that has been the center of attention is the Oumuamua. This strange interstellar object was discovered by accident in October 2017 by Robert Warwick, a postdoctoral researcher at the University of Hawaii's Institute for Astronomy. While scanning the skies above Maui for asteroids approaching Earth, he thought he had found what he was looking for. But upon closer inspection, it was determined that the orbit of the object did not make sense. After performing numerous calculations, it was found that the trajectory of the object was consistent with it originating from outside our solar system. This came as a major surprise, as many in the astronomical community had been seeking such a visitor for decades. Up until Oumuamua's arrival, no interstellar object was known to pass through our neighborhood before. Since it was first discovered at a facility in Hawaii, it was agreed that the object would have a Hawaiian name. Upon discussing what the object was and how it was found, the name Oumuamua was proposed. The word translates to it being called the first scout from a distant place. The shape of the object is one of its strangest properties. It has been compared to looking like a cigar floating through space. While it passed too far from Earth to appear as anything more than a dot, even through the most powerful telescopes, the way its light brightened and dimmed indicated that it has a stretched out shape. It is estimated to be at least 7 times as long as it is wide, but it is quite smaller than initially thought, as it is no bigger than 3,000 feet by 400 feet. Additionally, the object has been observed to tumble as it travels, completing one full flip about every 8 hours. While there are many realistic-looking illustrations of the object, astronomers are not yet certain about what it looks like up close. Oumuamua is also thought to have a reddish surface, but this is also yet to be confirmed. Its color seems consistent with other comets that are made of ice and rock. Additionally, the object sped up after it passed the Sun. This is likely because it was pushed by the outgassing of frozen material from its surface, a common characteristic among comets. However, upon observations by NASA's Spitzer Space Telescope, no evidence of a comet-like tail of gas and dust was found, leaving scientists perplexed. Oumuamua slingshot past the Sun at blistering speeds of 196,000 miles per hour, and its trajectory suggests that it had been wandering through the Milky Way, unattached to any star system, for hundreds of millions of years before finally entering our neighborhood. The existence of such objects was theorized for decades, but this was the first time one could be observed so closely. Immediately after its discovery, telescopes around the world, including ESO's Very Large Telescope in Chile, began to measure and observe its path, orbit, brightness, and color. Combining the images from the ESO telescope using 4 different filters with other large telescopes, astronomers found that the Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. This is very interesting, as no other known comet or asteroid in our solar system varies so widely in brightness and with such a large ratio between length and width. The reddish color of its surface also suggests that, similarly to other objects in the outer solar system, Oumuamua is completely inert. This means that the object is very dense and composed of rock and possibly even metals. It has no ice or water, and it turned red due to the effects of irradiation from cosmic rays over hundreds of millions of years. The massive telescopes continued tracking Oumuamua as it receded from our planet and started to fade into the distance. It was observed to be traveling at 85,700 miles per hour relative to the Sun. Its outbound path was about 20 degrees above the plane of planets that orbit the Sun. It passed the orbit of Mars first and then traveled beyond the orbit of Saturn in 2019 as it left our solar system and headed for its next destination, which seems to be the constellation Pegasus. Even though the origins of Oumuamua remain a mystery, some scientists speculate that the object could hold clues about the origins of life as we know it. Exactly how life on Earth originated is the focus of ongoing research across many disciplines. During the formation of Earth, many common elements and compounds would not have been present. Still, people believe that many of these, such as water, were delivered afterward by meteorites, which may have also delivered organic molecules. All these speculations came to an end by using new techniques of chemical analysis. These techniques helped Japanese researchers to demonstrate that components necessary to form DNA and RNA, the genetic basis of life, can be found in small meteorites that fall on Earth. According to scientists, the absolute abundance of nucleobases of extraterrestrial origin could be enough for further chemical reactions from the early Earth. These DNA components are not just examples of extraterrestrial life. Instead, they occur as a result of chemistry taking place on rocky objects in space called asteroids. Later, they may have fallen on Earth to provide the raw material for the origin of life. The idea that genetic material could form on asteroids suggests that DNA components are all over the place, which has a lot of implications when it comes to considering the potential distribution of life on other planets. Components of DNA and RNA have been found in meteorites before. Specifically, such space rocks have been found to contain nucleobases, the nitrogen-containing compounds that serve as the letters in the genetic code of our DNA and RNA. Nucleobases come in 5 primary flavors: adenine, or A, thymine, or T, guanine, or G, cytosine, or C, and uracil, or U. But previously, only adenine, guanine, and uracil had ever been identified in meteorites. In a new study, scientists reported finding all 5 nucleobases inside carbon-rich meteorites. This included trace amounts of all 3 pyrimidines: cytosine, uracil, and thymine. Although thymine and cytosine hadn't been found in meteorites before, laboratory studies hinted that these nucleobases might be lurking, undetected, in the space rocks that slammed into Earth. For example, in lab settings, scientists have recreated the chemical conditions of interstellar space, the space between stars, where immense clouds of gas and dust measure about 10 kelvins, and the parent asteroids of meteorites can be found. Through these experiments, researchers synthesized thymine, cytosine, and the other primary nucleobases, suggesting that all of these compounds could, theoretically, be detectable in meteorites. These findings inspired a team of scientists to go hunting for these nucleobases in 3 well-known meteorites called the Murchison, Murray, and Tagish Lake meteorites. These space rocks belong to a class of meteorites called carbonaceous chondrites, which are known to contain lots of organic compounds. In their latest study, the researchers used a technique called high-performance liquid chromatography, which involved using pressurized water to separate the meteorite samples into their components. In this way, the team extracted the nucleobases from each sample and then analyzed the bases using mass spectrometry, a technique that revealed the chemical makeup of the material in fine detail. This method enabled them to detect nucleobases with very low concentrations, as low as parts per trillion. The analysis revealed that all the meteorites carried adenine and guanine. The Murchison samples also contained uracil, while the other meteorites carried at least 1 uracil isomer, meaning a compound that contains the same number and types of atoms as uracil, but in a different spatial arrangement. In addition, the Murchison and Tagish Lake samples carried thymine, and the Murray meteorite contained thymine isomers. All of the meteorites contained cytosine, along with various isomers of the compound. There are different theories regarding the conditions needed for life to form on Earth. One of the most famous hypotheses suggests that intense ultraviolet radiation and lightning provide the energy for chemical reactions between compounds to begin on early Earth. These reactions then led to the creation of molecules such as DNA and RNA, which would ultimately become life. Experiments have confirmed that this theory might work. However, there are some gaps between the conditions simulated in these experiments and what we now understand about the early evolution of Earth's atmosphere. The challenge has led scientists to look elsewhere for how the earliest molecules formed. Other theories include reactions involving ice and glaciers, radioactive beaches, and meteorites bringing these materials to Earth. The latter is already known to have played a crucial part in the formation of life by delivering most of the planet's water. Meteorites also contain a variety of other organic molecules. The recent occurrence of DNA molecules in meteorites gets around some of the issues of them forming on Earth, as the delivery of these initial building blocks is essential for life to start. The researchers who located the first ever object from another solar system to reach Earth are now setting their sights on a new goal: scooping the remnants of an interstellar meteor up from the bottom of the ocean using magnets. After identifying a fireball that exploded and landed in the South Pacific Ocean in January of 2014 as an object from another solar system using classified government tracking data, Dr. Avi Loeb, a professor of science at Harvard University, is now hoping to locate remnants of the object. If successful, it would be the first time scientists can, quite literally, get their hands on material from another solar system. But Loeb's interest in the object is not relegated to merely learning more about rocks from space. Rather, Loeb has become a loud voice espousing a belief in aliens, and he believes there's a chance that the interstellar object may be a piece of key evidence for their existence. The window to grab this material was thrust open at the beginning of the month when a 2019 finding by Loeb and his student Amir Siraj, who is director of interstellar object studies at Harvard's Galileo project, which Loeb directs, was confirmed by the U.S. Space Command at the Department of Defense, which tracks objects in space using classified sensors. They published the initial finding with 99.999% confidence, based primarily on the velocity at which it entered Earth's atmosphere and the location within the atmosphere at which it began to burn up. This meteor, which landed off the coast of Papua New Guinea at 1705 UTC, moved at a velocity high enough to have traveled from another solar system and burned up at an altitude of around 11 miles above Earth, low enough that the object was able to penetrate through most of the atmosphere before it exploded. Loeb is careful to note that the interstellar meteor may well have a natural explanation, but he isn't ruling out that the 2014 object is a sign of life in other star systems. If you like this video, you may also be interested in this one, which talks about the detection of an alien object 25 times bigger than the Earth. Do you think this alien meteor could explain the origins of life? Please share your thoughts in the comment section below.